Hello all. Welcome to the second day of the Espressif Developer Conference 2023. My name is Amey Inamda and I'm Director of Technical Marketing at Espressif. I hope you enjoyed the first day when we had many interesting talks delivered by my colleagues. We are going to begin the second day by introducing all the new products, important features in our SDKs, and different solutions that we developed during the last 1 year. In this session, I'm going to talk about our two new SoCs, ESP32H2 and ESP32C6 that are now in mass production. I will also talk about some of the development kits that we made available recently. Then I'll talk about various SDKs that we have and what are some of the important features that we developed in the last 1 year. Then I'll give you an overview of how Espressif provides comprehensive support for building Matter devices using our hardware and software. Espressif also has a cloud solution, ESP RainMaker, and a remote device observability solution called ESP Insights. I'll talk about some of the new developments that we did in both these solutions. Then I will talk about a few of our new solutions that our team has built. And then finally, I would be glad to answer your questions that may come up. Okay, so let's begin with the new SoCs, ESP32H2 and ESP32C6. So ESP32H2 is our first 802.15.4 and BLE on the SoC. Yes, it does not have Wi-Fi connectivity. This is a single-core RISC-V MCU capable of running at 96 MHz with 320 kilobytes of RAM. This has all the required peripherals, and this is a very well-suited SoC if you are considering to build a thread product or a Matter product with thread protocol support or purely a ZigBee product. Again, this SoC continues to have the security features such as secure boot, flash encryption, and also has ECDSA-based digital signature peripheral, which acts as an integrated hardware secure element right within the SoC. Then ESP32C6 is Wi-Fi plus 802.15.4 plus BLE connectivity SoC. So yes, it has all the three radios. And then it is a single-core RISC-V MCU capable of running at 160 MHz. It also has a low-power core capable of running at 20 MHz, and that is also a RISC-V core. It has 512 kilobytes of RAM, and it basically uses the hardware coexistence to share the RF between all these three protocols. It has all the commonly required peripherals and also has support for peripherals such as two-wire or automotive interface as well as SDIO slave. Again, this SoC also continues to have secure boot, flash encryption, and digital signature peripheral type of security features required for building any secure and trusted IoT device. So now let's move on to the development boards that we developed recently. So the first one I would talk about is ESP32S3 Box 3, which is a successor of an older S3 box, which received overwhelming response from all the developers. So it has a very interesting form factor to work with. And in this specific board, we have added more memory, that it has more PSRAM, 16 megabyte PSRAM availability. The design is slimmer and sleeker, and it comes with different I/O expansion slots, which basically takes the usability to the next level. Then the next board I would like to talk about is a ESP Thread Border Router Devkit. It essentially is a two-module board or a two-chip board based on ESP32S3 and ESP32H2. It can be used for building a thread border router, but it can also be used to build some additional devices such as ZigBee to Matter Gateway or ZigBee to Cloud type of bridges. In this case, ESP32S3 acts as a master MCU and ESP32H2 acts as a radio coprocessor supporting 802.15.4 radio. With having a separate 802.15.4 radio, we can provide really high performance when it comes to a thread border router. And for this board, we have a complete reference design available, including the schematic, BOM, and also the software that is run on both the chips. Then the next board I would like to talk about is ESP32C3 LCD evaluation board. So this has very unique form factor. So this is a circular display with ESP32C3, and it also comes with a rotary encoder switch with 360 degrees rotation. The display is based on I2C and SPI, and it has 1.28 inches LCD screen with 240 by 240 resolution. Additionally, this board also has on-board infrared receiver and transmitter, so you can build remote control type of applications easily using this board. It also has a small speaker on board to provide audio feedback to the users. Of course, again, schematic and layout is openly available even for this. Now, let's talk about some of the SDKs and software features that we have added recently. So first to talk about is ESP-IDF. ESP-IDF, as you know, is the base platform that we provide to build all the applications on all different SoCs that we have. So we released new ESP-IDF version 5.1 in this June of 2023. And with that, the service period availability for this version will be till June 24. So all the patches will be ported actively till June 2024. And it will be in the maintenance period till December 2025. So the security patches will be maintained till December 2025. So if you are starting to build any new application right now, IDF 5.1 is the best SDK to start working with. This SDK supports newly announced ESP32C6 and H2 SoCs, and it also has multiple different software component upgrades such as Nimble BLE stack has been upgraded, Embed TLS stack has been upgraded, GCC, GDB, OpenOCD, these tools have been upgraded as well. The default C++ support also now has moved to C++23. In terms of Wi-Fi connectivity, it has support for Wi-Fi aware, that is neighborhood aware networks, and also it supports WPA3 using in the soft API mode. Of course, as ESP32C6 is supported, this SDK version also supports 802.11ax protocol. In terms of peripheral, it adds new drivers for event task matrix as well as parallel I/O interface. There are multiple new USB subsystem examples available that include USB camera, that is USB UVC, USB HID, host, as well as USB mass storage. ESP-IDF also has a special target called Linux, whereby you can compile IDF for Linux for an easy development. We have added for support for FreeRTOS, LWIP stack, TCP transport, and TCP TLS, even for the Linux target in this SDK version, so that your development on Linux platform becomes much easier. The next thing I would like to talk about is IDF Component Manager. So IDF Component Manager is equivalent to an NPM registry or PIP registry for Python. So ESP registry we maintain, which basically comprises of different components which you can use in your projects. So these components come from either from us directly or even from third parties. We are very glad to say that ESP registry is now open for public contributions. So you can have your own component built and you can register that with ESP registry using your GitHub account. We have released the complete documentation to allow you to do this, to do the same. We have also released GitHub CI action so that you can easily upload your newly refreshed component into the registry. We are very proud to say that we have 179 components already published and more than 20,000 component downloads per day. And yes, this download count does not include automated download that happens from the CI. To talk about the 802.15.4 software, because we have two new SoCs supporting 802.15.4 radio, we support Thread, ZigBee, both the protocols. On Thread side, we have open thread support present in ESP-IDF 5.1, and you can also use ESP32H2 or ESP32C6 just as a open thread radio co-processor with some other host. That support is also available in IDF. ESP Thread BR, this SDK basically implements thread border router and this implementation is now already certified for Thread 1.3. On Zigbee side, ESP Zigbee SDK is the SDK based on DSR ZBoss stack that we use internally, and it provides a bunch of examples for you to build Zigbee-based devices using ESP32H2 or C6 SoCs. Zigbee radio coprocessor functionality can also be used with, say, ESP32H2, and we have examples for the same available in this repository. In fact, we also have implementation for Zigbee to Matter bridge implementation, and then it is available in ESP Matter SDK. Now let me talk about two other commonly used SDKs by developers, Arduino and Zephyr. So Arduino recently announced Arduino Nano ESP32, which is the first official Arduino board in which ESP32S3 is used as a main processor. It uses Arduino ESP32 core that we have implemented to support Arduino. And on Arduino ESP32, we have started developing version 3.0, which is going to be based on IDF 5.1. There is also work ongoing to support ESP32C6 and ESP32H2 chips in Arduino. On the Zephyr side, we supported Wi-Fi protected modes, which also includes WPA3 support now. We have also added ESP32S3 support in Zephyr. Asymmetric multiprocessing, which was work in progress last time, has now concluded, and support for asymmetric multiprocessing is now available in Zephyr substrate repository. Also, ESP32C6 and H2 support in Zephyr is right now in progress. Moving ahead, Rust language is very important for us, and we see quite a significant promise in Rust language to build memory-safe embedded systems. So we have made good progress, and yesterday you heard from my colleagues about some of the developments that we did on the Rust side. Just to summarize them, we implemented async bare metal Wi-Fi support, so you can use Wi-Fi functionality even with the bare metal mode in the async fashion. Also, the bare metal support for ESP32H2 and C6 is ready. Standard library support for ESP32C6 is also ready based on ESP-IDF. And device driver supporting async mode is also available for both standard libraries-based implementation as well as bare metal implementation. As you know, some of our chips like ESP32S3 and upcoming ESP32P4 has quite a good AI functionality or machine learning capabilities. We also provide many machine learning SDKs from our side. You might have heard of ESP-WHO, which is an object or face recognition SDK, and ESP Skynet, which is the speech recognition SDK. But underlying these SDKs, we also provide you ability to build your own machine learning models with ease. There are two other SDKs which play that role. We have support for TensorFlow Lite Micro, which is a standard TensorFlow Lite implementation, which is optimized for SoCs like ESP32S3 to take advantage of its AI acceleration. However, a bunch of functionality still comes from TF Lite side, including the quantization decisions and so on. So to improve on the performance or to get the best possible performance, we also have a repository called ESP-DL. DL stands for deep learning. And one of the key features that we added recently to ESP-DL is TVM compiler support. TVM compiler basically provides a unified way to work with embedded systems with different GPU or TPU capabilities. So we have added support for ESP32S3 in the TVM compiler, and with that, you can use models such as TensorFlow Lite, PyTorch, or ONNX easily using ESP-DL platform supporting TVM compiler. So with TVM compiler, we get much reduced quantization loss, and also keeping the performance very good. So you can use standard models with best performance with this. Moving ahead, as you may know that ESP SoCs also are used for audio purpose. Customers build different audio-centric applications on that. And we have a SDK called ESP-IDF. We recently released version 2.6 for this SDK, which is based on IDF 5.1. multiple components of ESP-IDF can now be used in a separate component fashion, so that if you are interested in using a part of IDF, it's very easy to do that. Importantly, we also added support for software-based H.264 encoding in ESP-RTC. Now let me talk about Matter support. So as you know, Espressif has been providing quite comprehensive Matter solutions to all the developers. We have an open source SDK called ESP Matter, which is based on Connected Home IP SDK. Connected Home IP SDK is where the entire authoritative implementation of the specification is maintained by the community. So we have added support for all our different SOCs in Connected Home IP, and then we have built our own ESP Matter SDK on top of that. To talk about ESP Matter SDK, now has releases for both Matter 1.0 and 1.1 specification, and its master branch is currently tracking version 1.2 of Matter specification. We have also recently added support for ESP32C2 to support Matter devices over Wi-Fi. ESP Matter SDK now works with IDF 5.0 and 5.1. We also added support for Ethernet-based commissioning. And then, importantly, with ESP Matter SDK, the ESP32 series chips can also act as a commissioner. So they can provide a commissioning functionality to commission other Matter devices. At the same time, we also now have controller example available on ESP32, which can basically control other devices, other Matter-compatible devices. One more Matter-centric product that we have is ESP ZeroCode Modules, which essentially is a zero-code type of module where you can configure you can configure a module to act as a light bulb or a socket or any commonly used device type. So for that, we announced ESP ZeroCode Console recently, and it supports all the basic devices supported in Matter protocol. You can easily configure the I/O configuration and drivers connected to those I/Os to simply define your device and get a fully ready Matter firmware directly in your browser. Once your firmware is ready, you can easily use ESP Launchpad there itself to load that firmware onto your module and have a complete experience of a Matter accessory without going out of your browser. The next important thing on the Matter side is DAC pre-provisioning service. Matter has this concept of having a unique device certificate signed using CSN approved authority. So for simplifying our customers' manufacturing line, we support DAC pre-provisioning service, and this service is now available on all the different modules for all the different SOCs that we have. Now to talk about ESP RainMaker, which is Espressif's private cloud platform, and ESP Insights. So ESP RainMaker, as I told you, is the cloud software that you can deploy in your own AWS account, where you get complete control and you can build your own IoT cloud. Importantly, we added a support for Matter Fabric in ESP RainMaker recently. So with that, you can build your own Matter ecosystem where you can have your own Matter-compatible phone applications that can work with not only with your own devices, but also other third-party Matter devices. You can have the Matter device database synchronization across different controllers that you may have. And we also intend to take it forward to provide remote control for all your Matter devices through the controller that we. That is one of the important features that we developed recently. Now moving on, so we also supported command response framework in RainMaker. Earlier it was all device parameters updates based framework, but with command response framework, you can now have a synchronous communication between any other entity, such as phone apps and the devices. We also did a bunch of improvements on over-the-air upgrades capabilities by supporting MQTT-based OTA or priority-based OTA, and also user approval-driven OTA. To talk about ESP Insights, we improved quite many different metrics that come with ESP Insights. It also now has command response support, so you can selectively enable diagnostics on particular device or a particular set of devices. Alerts and notifications are now available for any behavioral anomalies that may happen in your systems enabled with ESP Insights. It also supports multi-admin support so that you can share the logs of particular devices with other users or other developers that you want to. And it also now supports connector functionality so that if you have your own cloud or if you have your own third-party cloud which is getting the diagnostic data, then you can build cloud-to-cloud connectors to have integration with ESP Insights. Now, let me talk about some of the new Espressif solutions that our teams have built. So the first one is ESP Mesh Lite. As you may remember, we have ESP Wi-Fi Mesh. ESP Mesh Lite is a successor of ESP Wi-Fi Mesh, and one of the key improvements that we have done is a complete IP connectivity to all the participants of the mesh. Earlier, you may remember that ESP Wi-Fi Mesh has different MAC-based communication within the mesh, and then the root node had to communicate with the IP network to the outside world. But in the case of ESP Mesh Lite, all the nodes get IP connectivity so that they can directly communicate, say, with cloud. There is no special infrastructure needed because now your router can absorb the root node, but all the intermediate nodes in the ESP Mesh Lite provide network address translation so that your main router is not burdened with so many devices. We also continue to reuse the good parts from the ESP Wi-Fi mesh, such as self-provisioning, self-healing. These features are already available in Mesh Lite as well. And also we have RainMaker integration available for ESP Mesh Lite. The next thing I would like to talk about is ESP-Now Matter Bridge. You may know that we have a coin cell operated button solutions. So you can have switches completely built on a coin cell and they can talk ESP-Now protocol. With this ESP-Now Matter Bridge implementation, basically any other device enabled with ESP32C3 or ESP32S3 type of SoCs can act as a ESP-Now to Matter bridge. It talks ESP-Now protocol on one side and Matter protocol on other side. So with this type of bridge, now all these low power ESP-Now devices can be first class citizen of your Matter network, and using device binding, you can bind these low power ESP-Now devices to control your own defined devices in your home which are Matter compatible. It gives you a lot of flexibility, and then it also improves the usability of these ESP-Now buttons to the great extent. We have worked significantly to enhance power consumption of both the button itself as well as ESP-Now Matter bridge. Then USB camera with LCD display. Imagine you have a video doorbell type of applications to be developed. So ESP32S3 with its JPEG decoding, the display capabilities of 800 by 480 resolution display, it can act as a USB camera display solution whereby it can take in the camera input and can also render it on the screen with 800 by 480 resolution at 15 frames per second. The video at the same time can also be transmitted to the mobile app that you may have. So with this, you can build real video doorbell type of applications. And we already have a reference implementation available on our GitHub. Then I would like to talk about ESP-Motor-Control, which is yet another solution from our side. And this is based on MCPWM and LED controller peripherals that ESP32 and ESP32S3 SoCs have. With this solution, we can support up to 4-way field-oriented control-based motor control, and also we can support sensorless motor control to implement BLDC type of applications. This project is also available through the Component Manager. So to conclude, as you can see, we have made significant progress in last year on so many fronts. Also, most of the development has been strongly developer-focused, and that is what our core DNA is. We will continue to move forward, and your feedback is very important for us to provide different solutions that are meaningful for you. Thank you for watching this session, and we can take your questions now.